Hi, in this video, I will be showing you problem number 15 from section 11.4 of your lecture handout. This is also a problem on the practice exam for chapter 11. Determine whether the series converges or diverges. Sigma n varying from 1 through infinity, 4 to the power of n plus 1 over 3 to the power n minus 1. We are going to use comparison test for this problem. If an is less than or equal to bn for all n, and if sigma bn converges, then sigma an also converges. If an is greater than or equal to bn for all n, and if sigma bn diverges, then sigma an also diverges. Let's consider the denominator of the given series, sigma an, which is 3 to the power n minus 1, which is less than 3 to the power n. So if we take the reciprocal, 1 over 3 to the power n minus 1 is more than 1 over 3 to the power n. Now we can multiply both sides by the numerator of the given series, namely 4 to the power n plus 1, 4 to the power n plus 1. So we'll consider sigma bn, the series to which the given series must be compared to, as the series on the right side of this inequality, which is sigma 4 to the power n plus 1 over 3 to the power n 1, 3 to the power n. This series can be written as sigma 4 times 4 to the power n over 3 to the power n, which in turn can be written as sigma 4 times 4 over 3 to the power of n. And this series is a geometric series with common ratio 4 over 3, which is more than 1, and hence it is divergent. So from this step, we have an, which is the nth term of the given series, is more than or equal to bn for every n. And also we have sigma bn is a geometric series, which is sigma 4 to the power n plus 1 over 3 to the power n, is geometric and it is divergent. And therefore by comparison test, sigma an, the given series, which is sigma n varying from 1 through infinity, 4 to the power n plus 1 over 3 to the power n minus 1, also diverges. Hope this video helps.